Hello everyone. Today we are going to discuss some factors affecting on acid hydrolysis along with some point of base hydrolysis. See the some factors affecting on the acid hydrolysis. Factors. First factor is charge on the complex. Second factor is about steric factor. Okay. Third is electron density. Around center metal ion. And fourth is about effect of a leaving group. Thus these are the four factors. First is the charge on the complex. Here one by one we will discuss here the factors. First factor is that is charge on a complex. As in a octahedral complex, as the charge on the complex is increase in charge of complex, it will decrease in rate of the reaction. Decrease in rate of a reaction complex. That is as it is follows the SN1 pathway, that is the unimolecular nucleophilic substitution reaction. For example, if we are getting example, that is CONH3 4 times here, that is a Cl 4 times Cl 2 plus, and considering CONH3 5 times Cl as a plus. Here, as far as in these two complexes, in which complex the charge is more, that is this is the first complex, this is the second complex. And considering the charge, as the charge is increases here, there is decrease in the rate of the reaction of a complex. That is, therefore, the reaction rate of this complex is lower than that of this complex. Okay. Now, the second factor is about the effect. The second factor, that is the steric strain. Effect of steric strain. The octahedral complexes. In an octahedral complex, in a central metal ion, it is surrounded by a number of ligands. If the ligands are substituted, then the rate of a reaction is much faster than, therefore, the rate of a reaction much faster than the unsubstituted ligands. What is my statement here? In case of this steric strain here, that is in octahedral complex, what happens here? That is, if the ligands are substituted, at that time rate of a reaction is much faster than the rate of a reaction in which the ligands are unsubstituted. For example, we are drawing here the examples. That is, ethylene diamine, here CH2, NH2. Okay. Second example is about CH3, CH, here NH2. Okay. Now the third example is that is the CH2NH, here CH3. In these examples, we have said that is the presence of a bulkier group, that is the spectator ligands due to bulkiness and due to the steric strain, they enhance the rate of a reaction without participating in a chemical reaction. That is the spectator ligands means what here? That is the ligands which cannot take part in a chemical reaction of a complex, but they can enhance the rate of a chemical reaction in which they are chemically bound to each other. Okay. Thus, here the presence of the bulkier group, in these examples, the presence of a bulkier group, and due to the steric strain, they enhances the rate of a chemical reaction than the unsubstituted ligands here. Okay. Now the third factor is about that is the effect of electron density. Effect of electron density around the central metal ion. Around the central metal ion. Now, in case of pyridine, for example, in case of pyridine and in methylpyridine, these are the examples of a electron donating species are, okay. That is, these are electron rich spacing, okay, which are when bound to a nucleus, they can donate the electron pair towards the nucleus. When these types of ligands, when bound to the electron, bound are around to a central metal ion, at that time what happens? The electron density is directly transferred to a central metal ion. Thus, by weakening the bond between the central metal ion, if it is M, that is a central metal ion, and the bond between the leaving ligand, that is, this bond becomes weakens now, and thus there is an increase in the rate of a reaction. But actually it cannot be happens, because in a coordinated octahedral complex, there is a ligands is of cis and trans effects also. The series for this is we have considered in a leaving group of series. Thus, when the electron density around a electron rich ligands which are directly bound to the central metal ion, at that time they enhances the electron density towards this central metal ion, and thus the rate of a reaction is increases now. Now the next point is that is effect of a leaving group. Effect of leaving group. Now we know that already the first step in a SN1 reaction is what? That is the dissociation of a leaving group, that is the breaking of a bond between the central metal ion and the leaving group. That is, the leaving group is having the marked effect on the rate of a reaction. Already experiments have been found that the series is known as here, that it plays the important role. A large effect in case of SN1 reactions, the series is known as a SCO3 is greater than NO3 minus is greater than here, I minus is greater than here, Br minus is greater than Cl minus is greater than F minus is greater than S is greater than CH3O minus is greater than here also a CNS minus is greater than NO2 minus. This is a good agreement with decreasing thermodynamic stability of the complexes. thermodynamic stability of complexes with these groups. And when this is a possible one, that is when the complex follows the SN1 reaction mechanism. That is, this is one holds for this SN1 reaction mechanism, and the anion order is of SCO3 bicarbonate here of anion NO3 minus, I minus, greater than Br minus, greater than Cl minus, greater than Brf minus, greater than OCH3 minus, greater than CNS NO2. This agreement with the decreasing thermodynamic stability of this complex. That is, as these groups are present in the complex, there is decreasing thermodynamic stability of a complexes. Thus, we have here explained here the factors affecting on the acid hydrolysis. Now we go for this base hydrolysis. Okay, see here the definition. Second point, that is the base hydrolysis. Definition: in an octahedral complex, when the ligand present in a coordination sphere of a complex is replaced by anion of water, anion OH minus of a water, the hydrolysis is known as what? That is the base hydrolysis. Base hydrolysis. What? That is a ligand present in a coordination sphere where it is replaced by anion of a water. The hydrolysis is known as a base hydrolysis. For example, the reaction is like this: CONH3 5X2 plus here OH minus. Here formation of this CONH3 5OH minus of 2 plus X minus. Actually, by seeing this reaction to be followed in a SN2 type, but actually in SN2 reaction pathway there are some limitations. Therefore, this reaction follows the path of a SN1 reaction, but actually it is not a SN1, it is a CbSN1. It is a path of a which? It is a CbSN1. Cb means what here? Conjugated base of a unimolecular nucleophilic substitution reaction. Okay, thus I am going to just revise you the reaction as. See here the reaction. That is CONH3 5X2 plus OH minus here, reversible reaction here. That is, there is formation of here CONH3 5OH2 plus X minus. Number of reactions passing through this here. First step is what? That is first CONH3 5X2 plus gives rise to here plus O. In this here, first step is what? That is the of OH minus here plus OH minus here. That is of CONH3 4 NH2 and here H, NH2, and here 1 plus here plus H2. This is a conjugate base, okay, of amine complex, and this is a conjugate acid. Conjugate acid 2. This is the conjugate acid 1. This is the amine complex. According to Bronsted is called as acid 1. This is called acid 2, and this OH minus, it is called as a Bronsted base 1. Yeah. Okay, and here this is called as a base 2 here. Okay, this type of reaction takes place, that is this conjugate base amine complex is a conjugate base of this amine complex. Now again the reaction is follows at this type, that is CO NH3 4, that is NH2 plus here also H2O. There is formation of here what? This is the first step here also, and this is the slow step here also here. Now here the formation of this first. This is NH2 plus H2O here. Okay. Now in the first step here, NH2 and X here NH2 X here, and there is formation of here CO. This is a slow step. Okay, CO NH3 4 NH2 here 3 plus X minus. Now the last reaction is goes on this way here. Formation takes place here as from this here, that is CO NH3 4 NH2 plus OH minus. Okay, there is formation of CO NH3 5 OH minus. Okay, thus having the CN is equal to what? That is equal to a octahedral 1. In the next lecture we are going to discuss this hydrolysis in detail form, how the common base is arises or the conjugate base is arises from the amine complex. What is the Bronsted-Lowry definition of an acid, of a conjugated base, and its mechanism. Okay, I hope that all of you understand this video very carefully. If there are any doubts, please ask me on group. Thank you.